You know that feeling when you're scrolling through social media? It's just so
Fire.
much stuff.
Oh, yeah. A total fire hose. Twitter, Facebook. It's endless.
Right. Mountains of data every
Yeah.
single day. And trying to figure out what's actually, like, important, what real events are happening and all that noise. It
Mhm.
feels kind of impossible sometimes.
It really is a deluge. The scale is just immense. Makes it super hard to find the real signals, with the usual ways of looking at data.
Exactly. So for this deep dive, and this is specifically for you,
Uh-huh.
the learner, we want to give you a new way to cut through that clutter.
Okay.
Our goal today is to really understand this new method for automatically spotting significant events right when they pop up online, so you can pinpoint what actually matters.
And why is this so relevant for someone who wants to learn things quickly but, thoroughly?
Well, because it's like a shortcut, isn't it? Instead of
Yeah.
you having to wade through everything, trying to connect the dots,
Mm-hmm.
this new approach, it aims to intelligently flag the key stuff. Think of it like a smart news feed that doesn't just say what's happening, but gives you the context straight away.
Okay, interesting. And our source for this.
Yeah, we're looking at a research paper. It's called WhatsUp, an event resolution approach for co-occurring events in social media, published in Information Sciences.
Right. So it tackles this exact problem head on. Automated event detection in social media.
Yep. And our mission here is to really kind of get under the hood of this WhatsUp method. How does it work? What makes it different? And crucially, what are the key things for you to take away to stay better informed?
Sounds good. So where should we start? Maybe with the old ways. What are the existing methods like, and where do they fall short?
Good idea. So a lot of current systems, they lean really heavily on just counting stuff, right? Data statistics, like how often words appear.
Frequency, basically.
But that often misses the nuances, the actual language being used.
Right. Just knowing a word is popular doesn't tell you why or if it relates to a specific new event.
Exactly. The paper uses car as an example.
Mm-hmm.
Might be mentioned loads, but doesn't mean there's some big car-related news breaking,
Precisely. Frequency alone isn't enough. It lacks that event context.
Okay, but what about methods that do try to understand the language?
Yeah.
The linguistics. Do they have limitations too?
They often do. Sometimes they focus too much on what the event might be about the text itself, but they're not great at nailing down when it actually happened.
The timing aspect.
Yeah.
Which is pretty critical for unfolding events, right? Old news isn't really news.
Exactly. Timeliness is key. And another thing the WhatsUp researchers point out is that standard pre-trained language models can kind of struggle with social media language.
Oh, right. Because it's so unique.
Yeah. Think about all the slang, the abbreviations, even like creative typos and emojis.
Mm-hmm.
A general model, one trained on, say, news articles or books, might not fully get the meaning or the context there.
Like trying to understand a local dialect with just a standard dictionary, it misses stuff.
Exactly. It's not tuned for that specific environment.
Yeah. Which brings us nicely to what's up. So what's the big idea here? What makes it different?
Okay, so WhatsUp tries to combine the best of both worlds. It looks at the statistics and it digs into the linguistics.
Right.
And it does this to figure out both the timing and the actual textual details of events.
Ah, okay. Getting the when and the what together. And how does it handle that tricky social media language?
This is key. It uses something called self-learned word embeddings.
Self-learned. Okay, what does that mean practically?
So imagine giving each word a sort of numerical code representing its meaning and how it relates to other words. Self-learned means WhatsUp creates these codes from scratch based only on the specific social media data it's looking at right then.
Oh, so it learns the local lingo, basically. The slang, the context, everything specific to that conversation.
Precisely. It becomes fluent in the data it's analyzing, which helps overcome those limitations of the general models we talked about.
It sounds much smarter for handling messy online talk.
Definitely. And another big thing, it's designed to spot co-occurring events.
Meaning?
Meaning it can identify multiple different things happening around the same time within the same data stream, not just one dominant topic.
Okay, like following several different stories breaking at once.
Oh.
Got it. So how does it actually do all this? What are the mechanics?
Well, the first step is breaking down the data flood. It uses time windows.
Time windows, like snapshots.
Exactly. Imagine taking snapshots of the social media feed at regular intervals. Maybe every few minutes, maybe longer. These are the time windows.
Okay, makes the stream manageable.
Right. And the paper mentions you can adjust the length of these windows. Like for fast-moving sports, you might use shorter windows than for, say, slower political discussions.
Makes sense. A goal happens fast, a policy debate takes time. Okay, so you have these windows. What happens inside them?
This is where the language part kicks in. Within each window, WhatsUp learns those word embeddings we mentioned.
The meaning codes for the words used in that specific window.
Yes, capturing the context of that moment.
And what does it do with those codes?
It uses them to build these diagrams called dendrograms.
Intrigrams. Sounds complex.
Think of them like family trees for words. Based on the embeddings, words with similar meanings or usage get clustered together on branches.
Ah, okay, so it visually groups related words within that time window.
Exactly. It shows the semantic structure, how words are related then.
Cool.
Yeah.
Now, I remember reading something specific about how it measures similarity in those trees, LDL.
Yes, that's a really clever part. It uses local dendrogram level similarity, or LDL similarity.
Local? Why local? What's the benefit over just a standard similarity measure on that tree?
Well, standard measures can get thrown off by noise, random words that pop up in social media but aren't really part of the core event.
Like our car example, maybe?
Yeah.
Just floating around but not relevant?
Exactly. LDL focuses on the closer relationships within the tree structure. It looks at the immediate neighborhood of words, so it's less likely to get confused by those irrelevant noise words scattered further away in the tree.
So it's more robust. Better at handling the messiness of real social media feeds.
That's the idea. The paper shows an example, I think, with football terms like goal and player names.
Yeah, Rashford and Firmino.
Right. In clean data, both standard and LDL might work fine, but add noise words, and the standard measure might get confused about how close goal is to the scorer. LDL, being local, holds up better. It keeps focusing on that core relationship.
Okay, that's a really important detail for making this practical. So LDL helps understand relationships within a window. What's next?
Next, it looks at how things change between consecutive time windows. How do those word relationships evolve?
Ah, tracking changes over time.
Yes, specifically using something called positive similarity change.
Positive change. Why focus only on positive?
Well, think about an event starting. Words related to that event suddenly start being used together much more, right? Their similarity, their connection increases.
Okay, yeah, like protest and downtown might suddenly become much more closely linked.
Exactly. WhatsUp specifically looks for these increases in similarity. It's a strong signal that something new is emerging, bringing terms together.
As opposed to just any change, like words becoming less similar.
Right. Just looking at any change might pick up topics fading away, which isn't really a new event. Focusing on the positive change helps zero in on emergence. It's about words becoming more related, signaling a developing story.
Makes sense. Pinpointing the start of something. Does it look at anything else besides these similarity changes?
It does. It also considers changes in the vocabulary itself, the actual words being used.
So.
Using a metric called frequency difference-based vocabulary change, or FDVC.
Okay, FDVC, what's that checking?
It's not just about any new word appearing. It looks for new words that appear and show a significant jump in their frequency.
So not just a one-off mention, but a new term that suddenly gains traction.
Exactly. It helps filter out those fleeting words that aren't really part of a sustained event discussion. A new keyword that rapidly becomes popular is a much stronger signal.
Okay, so you got LDL measuring robust similarity within windows, positive similarity change tracking the emergence of relationships between windows, and FDVC spotting significant new keywords. What happens then? How does it pull out the actual events?
Right. So after analyzing all this, WhatsUp identifies time periods, event windows, where there's a lot of this significant change happening.
Okay, so it knows when something interesting is likely going on.
Yes. But within that window, remember, there might be multiple things happening, those co-occurring events.
Right.
So the next stage is event cluster detection.
Clustering. How does it group things?
First, it ranks the words within that event window based on how much their relationships changed, using a mix of the LDL similarity changes and the frequency changes, FDVC.
So words with the biggest positive shifts rise to the top.
Exactly. Those are treated as likely keywords, the core terms for the different events. Then it basically groups other words around these keywords based on linguistic similarity, using those word embeddings again. Words that are similar in meaning get pulled into clusters around the main keywords.
Forming distinct groups, each representing a different event.
Precisely. Each cluster represents a potential co-occurring event being discussed in that window. The paper mentions you can use thresholds, like how similar words need to be, or just take a fixed number of related words for each cluster.
And these clusters get a score, too.
Yeah, a novelty score, which basically indicates how new or significant that particular event cluster seems compared to what was discussed before it.
And didn't you mention it clusters individual words and emojis, not whole posts? Why is that useful?
Yeah, that's quite neat. Because one tweet or post might talk about, I don't know, a football match and the weather and politics, right?
Happens all the time.
By clustering at the word token level, WhatsUp can potentially untangle those different threads even if they're mixed in the same message. It can also spot links between related words even if they don't appear right next to each other. It's more granular.
Giving a cleaner separation of the different conversations happening. I think that sounds really promising conceptually. But did they test it? How well does it actually work?
They definitely did put it through its paces on real Twitter data.
What kind of data?
Two very different sets. One was live tweets during a big English Premier League match, Man United versus Liverpool. Very fast-paced.
Okay, lots of action there.
And the other was political tweets during the UK's Brexit Super Saturday parliamentary vote. A different kind of intensity, maybe slower developing discussion points.
Good contrast. Fast sports versus slower politics. And they compared WhatsUp to other methods.
Yes, against several existing state-of-the-art event detection techniques.
And the results. Drum roll, please.
Well, the key finding, and this is pretty striking, is that WhatsUp outperformed the other methods across both datasets.
Outperformed how?
Both in identifying the timing of the events correctly and in terms of the relevance of the events it detected.
So better at saying when something happened and what it was about.
Exactly. They used metrics like the time window F1 score, which measures how well the system identifies the correct time periods for events. WhatsUp consistently scored higher.
Meaning you're more likely to get timely and accurate event alerts from it.
That's the implication. And they did something interesting with their evaluation setup, too. They created an updated ground truth.
What does that mean?
They realized that official news timelines don't always match perfectly with when things actually blow up on social media.
Right. The online buzz might start earlier or peak differently.
Precisely. So they manually went back through the Twitter data for those events and refined the timings based on the actual social media activity peaks. This made their comparison even tougher and more realistic.
That's thorough. Shows they were serious about testing it properly against real social media dynamics. What about speed? Gotta keep up.
Good question. They looked at processing times, too, and found WhatsUp was efficient enough for near real-time detection. It wasn't too slow to be practical.
So, accurate and reasonably fast. Any downsides? Like, is it hard to set up? Does it need lots of tweaking?
They did look at parameter sensitivity, how much the settings affect performance.
Yeah.
Well, like most complex systems, the optimal settings can depend a bit on the data and what you're looking for. For example, they suggest that for faster domains like sports, you might adjust things like similarity thresholds compared to slower domains like politics. But they provide guidance on reasonable starting points.
So, some tuning might be needed, but it's not presented as a major hurdle. Okay, let's bring this back to the learner. What's the big takeaway here from this deep dive into WhatsUp?
I think the core benefit is clear. WhatsUp gives you a potentially much more insightful and accurate way to track what's actually happening on social media.
Yeah, it moves beyond just word counts or simple trends.
Exactly. By cleverly blending that linguistic understanding, the self-learned embeddings, the LDL similarity, with the statistical tracking of changes.
Like a positive similarity change in FTVC.
It gets you closer to the real events with better timing and context, faster, richer understanding.
So that initial problem, feeling drowned in the social media flood.
WhatsUp seems like a really promising approach to help navigate that.
The aha moment is realizing you can potentially filter the noise more intelligently. Getting that richer picture by capturing language nuances and co-occurring events, it's a big step up from just keyword alerts.
Absolutely. And the potential applications seem huge.
So definitely. You can imagine journalists using this to spot breaking stories faster.
Researchers tracking public opinion shifts in real time.
Businesses monitoring reactions to a product launch or crisis.
Or even just, you, the learner, staying on top of specific topics you care about without getting bogged down.
Yeah, it really could change things. Which leads to a final thought for you, the learner, to maybe mull over. How might this kind of capability automatically, accurately detecting events in the social stream, how might that reshape the way we all consume news and understand what the public is thinking or talking about.
That's a big question. The implications are pretty profound, aren't they? If the signal can be reliably extracted from the noise like this.
Exactly. Something to think about. And hey, if you're technically inclined, the researchers even made the WhatsUp code available on GitHub, the links in the paper, so you could even explore it yourself.
Very cool.
Well, thanks for joining us on this deep dive into WhatsUp.